In this section, I want to put some of those principles to use. I want to take all of our employees, the hierarchy that I've assembled in the previous section, put them into a collection of superclass type, of type employee, loop over them all, and invoke the abstract method. Of course, it's implemented in all of the individual subclasses, and watch this process occur. I also want to step through this with the debugger so that we could see how the invocation of various constructors winds up calling the parent constructors as part of the basic process. So returning to this, I now have a class called HR. HR, my human resources class, if you will, has a collection of employee called employees. This is a list on the left-hand side and an array list on the right-hand side. So the list is the interface type, and we're going to come back to collections and talk about them a bit more later. Here is the generic type, employee, and on the right-hand side, I'm using what's known as the diamond operator, less than, greater than. The implication being is that I don't have to specify that the argument here is employee, which is what you used to have to say prior to Java 7. But in Java 7 and above, you can leave that out, and the type will be inferred from the type of the reference that it has been assigned to. So that's easy enough to do. I also added a hire method, which adds an employee, and a layoff method, which removes it, but I'm not going to use that method. I have a getter in case I want to see them all. And here we're seeing our first exposure, unless you've seen it in a previous course, to a method reference. This is using the employees collection with a for each method. Now, for each is a method that has been added to iterator. And when we talk about interfaces shortly, this is something called a default method. In other words, there was an iterator long before. There's been an iterator interface in Java since 1.5. And what was done is they added a new method called for each to it. Now, normally if you add a method to an interface, you break all the existing implementations until they implement the method. Now in Java 8, you can add a method as a default method, giving it an implementation, a default implementation. And now all of the existing implementations automatically inherit that method and they use it themselves. They can override it if they want, but in this case I want to use it. What the for each method does is it takes as an argument something called a consumer. And a consumer is one of the new, if you can see that, a consumer is a new interface added in Java 8 in the java.util.function package that takes each element and uses it up. It basically takes one argument and then returns void on that. System.out.println would be the normal way I would write this, but you can write this as a method reference with the colon notation saying I'm invoking the println method in system.out, and this is an example of using another method in a different class as a lambda. And a for each takes a consumer requires an implementation, and println is going to be my method that takes a single argument and then returns void. We'll come back to that later when we talk more about Java 8 lambdas in general and method references. I also have a pay everybody method. Now for pay everybody, I have a traditional for each loop, the loop that's been around in Java since 1.5, where I say for each employee in the employees collection, let's print out paying the name and then the amount, and I want to discuss this situation as well before we run all this. Now I'm going to add a quick demo here. I'm going to call it a currency printer, because this is another example of the usage of abstract classes inside the Java API. If I want to print currency, let me say that I have a double amount, which I'll call 1234567.8901234. So this is just a bunch of numbers written in a row, and I want to print that as though it was currency. Well, Java has a class called number format, and you see that it's in the java.text package, and I'll just refer to a reference called NF. Now normally what you would write on the right hand side is a new number format, but number format is in fact an abstract class. So what they have provided is number format has a method called getCurrencyInstance. Now notice this is a static method because I can't call an instance method unless I have an instance, and if I have an abstract class, I can't have an instance. There is no instance. So getCurrencyInstance is static, and it must instantiate something that ultimately is assigned to a number format reference. Now that's actually an interesting question, and I want to spend a moment on that. This is called a factory method. A factory method is a design pattern that means something is being instantiated somewhere, and we're going through a method to do it. Since number format is an abstract class, I can't instantiate number format, so I need a factory method in order to instantiate it. Also, because number format is abstract, I make that method static. Otherwise, as I say, I would need an instance in order to make an instance. So the real question is, what in the world is getCurrencyInstance returning? What is it instantiating? And more importantly, what's that relationship to number format? And if you think it through, you realize that getCurrencyInstance must be instantiating a child of the number format class, a concrete child. The question is, what does getCurrencyInstance return? And I'm going to show you that we can find out what it returns, and it will be a child of number format. First, though, let me run this. So I'm going to print out nf.format of that amount and show you what it looks like. And when I run this, I'm doing the getCurrencyInstance in the default locale, which in my case is US English. So you can see that I get commas and 2 digits past the decimal place and dollar signs and everything. Now there's an additional currency instance method. If I say number format.getCurrencyInstance, that takes a locale as an argument. So I'm going to use the overload of getCurrencyInstance that takes France as a locale. And when I run this one, now I get spaces where we normally would see commas, and a comma where we normally get a dot, and a euro symbol and everything. So I'm not really concerned about the details of the getCurrencyInstance method necessarily. I just want to show that we can have an abstract method or an abstract class that has a factory method that allows us to do this. Now I mentioned we could also find out what the class was that was being instantiated. That's easy enough to do. I'll simply go to my number format reference and call getClass to get the class reference on it, capital C reference, and I'll call getName so that I can see just the simple name on that. And when I run that, you'll see that I'm actually getting an instance of the decimal format class. The decimal format class is very powerful, has lots and lots of methods in it. Basically, the getCurrencyInstance method is a simple facade over decimal format. It allows us to customize decimal formats for currency in the current locale or whatever locale has been specified. So there's an example of an abstract class using a factory method for a useful purpose. Now back to my human resources one. In my pay everybody method, I use the getCurrencyInstance method to get a number format and format the pay. Now to use this guy, I created a human resources object, and I hired a couple of salaries and hourlies, both in by giving them a name and then by using the default constructor, and then I'll print everybody, which will print all the names, and then I'm going to pay everybody as well. So in order to see what this looks like, if I simply run it, you'll see the output is that I have each of the employees with the toString method that I generated. I'll show you that later, with the ID, the name, and the hire date, and then all the paying statements. And notice, of course, the names on the salaried and hourly that I did with the default constructor are unknown. Here's the interesting part, however. I want to run this through the debugger, and we can watch the various constructors happen. So I'm going to put a breakpoint right here when I'm hiring the new salaried employee. And when I run in the debugger now, then I'm in main, and if I now step into this, notice that I'm on the single argument constructor for salaried. And the single argument constructor, and my IDE is showing me that the name here is Fred, that's what was being passed in as an argument, is going to call this with name and default salary. If I step in again, now you see I'm on the 2-argument constructor for salaried, because this with name and default salary invoked the multi-argument constructor here. Now that calls super with just the name. So if I step in again, Now I'm up in the single argument constructor in employee, which passed the name along. The name is still Fred. That was the name being passed in originally. It has now been passed up to employee. That will increment the ID, set the name. I'm going to step over invoking the hire date. I don't want to go into library code here. And that will go ahead and initialize the salary. We're back in the salary class now. And this will then assign that salary that was passed in to the salary attribute. And when I step back again, now I'm back in the single argument constructor for salaried, and then back here in the hire method. Now that we've seen what happens when we go through the single argument constructor on salaried, I put a second breakpoint at the default, the default constructor on salaried as well, so we can watch that process also. We're now on the default constructor for employee. When I step into that, that's going to take me to the one argument constructor on employee because I used this as a method. And now what would first happen here, which we're not going to see because we're not seeing the library code, is this would then invoke the default constructor in object, the parent of all the classes. But we're not going to see that, unfortunately, because we're not stepping into the library code through this debugger. At any rate, I can go ahead and do all the assignments here for the date. Now I'm back in the default constructor for employee, and then back in the default constructor for salaried, and now I could go on and just complete the print here. I think what I will do is I will also put a breakpoint at pay everybody. And now if I proceed to that one, let me step into that, and you'll see here I'm in my loop that's going to work through every individual employee, meaning salarieds and hourlies. And when I step in now, it's going to say paying everybody with the get name, and notice I'm in get name in employee. And now I'm going to go to the get pay, which went to the salaried get pay because the employee I happen to be on was a salaried employee. So when I walk through the next one and do get name, I'm fine. And when I do, there's the get name for the hourly. Now, of course, I'm still in the employee class because the implementation of get name is employee. But here, when I call get pay now, I'm in the get pay for the hourly class. And that's the process. So I can let that run to completion. And when I go back to my output, you can see all the values being printed out as stated. So there you can see the process that when you build abstract classes or when you build collections, you often make a collection of abstract types, fill it with child types that you can actually instantiate, concrete types, loop over the collection, invoking the common method in all of them. In this case, I had get name, which was already implemented in the parent, and get pay, which was implemented in all of the individual children. And as they say, and I wish I was making this up, by the magic of polymorphism, they really do say that, each one did the right thing. So part of the motivation for abstract classes, for an inheritance hierarchy in the first place, is to build a collection of superclass types, populate that collection with subclass instances, loop over the collection and call the right method, and everybody does the right thing. So there's a basic summary of using abstract classes together with abstract methods, and both from library classes and in our own classes, and how they can be useful in your development.